Today we are going to go over the fundamental theorem of calculus. So this topic is super important. Every year approximately 10 to 20 points. So first concept, average value of any given function. So function f, the average value of fx. So the average value for function f of x is given by 1 over b minus a integration a to b fx dx. So a and b are the lower and upper boundaries. So let's have a look at some of the examples. Find the average value of fx on the closed interval. So 0 to 3. So the average value of fx is given by 1 over b minus a integration from 0 to 3 fx dx. So it's 1 over 3 times x cubed over 3, 0 to 3, and we plug 3 in. So the final answer is 3. Same thing for b. So integration 1 over 11 minus 3 from 3 to 11 square root of x minus 2 dx. This problem you can use u substitution. So u equals x minus 2, du is dx. This integration becomes 1 over 8 integration square root of u du, and the boundary when x equals 3, that's 1. When x equals 11, that's 9. Times u to the 1/2. So it's u to the 3 over 2, 2 over 3, 1 to 9. You can plug it in. And the last one, this is super important one. Find the average acceleration. So we want to find the average acceleration. Inside of the function has to be integration b minus a, so a to b, acceleration dt. Be careful. Average acceleration has to be acceleration inside. So because this is 1 over 2 acceleration, the velocity is given. We take the derivative. Give us 3t squared minus 4t dt. Okay, this is how we evaluate the average acceleration. And also, based on what we learned before, average acceleration is also given by v2 minus v0 over 2 minus 0. So both ways are okay. So next important concept is the first fundamental theorem of calculus. If we know f prime, the capital F prime equals fx, when we take the antiderivative of fx, will give us f of b minus f of a. And more important formula is given right here. So f of x equals f of a plus a to x f prime dt. So there are so many problems we are going to use this formula. For example, how do we evaluate f of 2 given f0? So f of 2 will be f0 plus 0 to 2 f prime dx. Keep in mind that has to be f prime. Or sometimes we look for position at 2 equals position at 0 plus 0 to 2. So the derivative of position gives us velocity. Also sometimes capital F of 2 equals f0 plus 0 to 2 f prime dx. And f prime, we know is lowercase f. So this is more popular on the AP test. The second fundamental theorem of calculus gives us how do we take the derivative of any given integral. So the derivative from integration from a to x F.T. dt. Be careful. Here a is a number. And here has to be x only. If it's a function of x, we have to use the chain rule. So if you look at here, both g of x, the lower and upper boundaries, not a constant, not x only. When we do this, we have to use the chain rule. I'm going to show you more examples. So let's have a look at example 9. You can pause the video for 2 minutes and try to solve example 9. So example 9, given the function from 1 to 3, fx dx equals 2.3, and also we know f prime equals lowercase f. So f3 minus f0 will be 0 to 3 f prime dx. And we know f prime is lowercase f. So from 0 to 3, given from 1 to 3, so this will be equal to 0 to 1 f dx plus 1 to 3 f dx. And 0 to 1 f dx is the area here, which is 2 times 1 plus 2.3. Final answer will be 4.3. So next, example 13. Let fx be an antiderivative of this. That means f of x derivative give you this function. If f of 1 equals 0, then f of 9. So f of 9 equals f of 1 plus integration 1 to 9 f prime dx. Now we just plug this in, use our graphing calculator. Let's look at more examples. Let me go over some problems. So example 2, we have absolute value function here. Every time we see absolute value function, we know it's a V shape, and our vertex, which also our split point or break point. How do we find the break point? We just need to set whatever inside of absolute value equals 0. For example, this one, we set 2x minus 3 equals 0. So x equals 3 over 2. So now we see x equals 0. The break point is between negative 2 to 2. So now we have to split this into negative 2 to 0, plus 0 to 2. When x is negative, as we know, how do we get rid of absolute value? So when we take off the absolute value sign, this will become negative x minus 3 dx. So when x is positive, when we get rid of x, the absolute value, it will become the positive x. And then we can evaluate each one. So similarly, for this one, because 3 over 2 is 1.5, it's between 1 to 5, we have to split this into 2 intervals here. So when x is less than 3 over 2, 2x minus 3 will be negative. So when we get rid of the absolute value sign, we have to add a negative in front. And when it's positive, it will be itself. Then we can evaluate each. Let me go over some second derivative problem. Example 3. So when we take the derivative of an integral here, the lower boundary is constant, upper boundary is x. Directly, our final answer, we just plug in x. That's our final answer. However, if the order of the lower and upper boundary is switched, before we take the derivative, we are going to take a negative out, 0 to x t cubed dt. Now we can take the derivative, give us negative x cubed. And if you look at d, lower boundary is a number, good. Upper boundary is x squared. In this case, when we plug x squared in, so it's x to the 14 plus 1 times the derivative of x squared give us 2x. But if you look at d, the lower boundary is not a constant anymore, and the upper boundary is sine of x. So in this case, we plug sine of x in. So it's 1 plus sine of x squared times the derivative of sine give us cosine of x. Minus, now we plug x in, 1 plus x squared times the derivative of x, which is 1. So our final answer would be 1 plus sine squared times cosine minus this. So be careful when the lower and upper boundaries. The lower boundary is not a constant, upper boundary is a function of x. We have to use the chain rule. Let me go over example 5 right here. So lower boundary not a constant, upper boundary also is not of x only. In this case, we have to use the chain rule. We just need to plug t using cosine of x, then multiply the derivative of cosine, give us negative sign. Minus the lower boundary, we plug x squared in, times the derivative of x squared give us 2x.